Alrighty. So let's get going. So today, just like yesterday, we're going to be working on the same old, our favorite binary protocol that for some reason is still being used despite, despite the world moving on to IP-based stuff and computers. We're going to be working on SCTE 35. So today is just going to be a short one, or rather tonight, just because it's actually Saturday here, so I don't want to be on too long. From all the stuff that we've been working on so far, we've got a decoder working, we've got encoding slightly working maybe, haven't tested it yet, but tonight all I want to do is just try and tidy up some of the stuff that's left over from the old Comcast package that we originally based this project on. There's a few little bits and pieces that we can tidy up as well. Things like I'm doing things like creating buffers and then like putting bytes in and then finally appending that to another buffer. But the standard library actually gives us something. So instead of using put uint, I want to change to use append uint. So that's one job we're going to do. Another one is just rename a few constants to be shorter. What else have we got here? I'll just delete a few more debug. So remove debug prints. Got a few things. Oh yeah, so rename constants and some struct fields. Yeah, that's pretty much it. So just a general tidy up. Deleting, old, dead code. So that's what we got. Let's just get cracking. Should be pretty easy. So, actually, first thing we're going to do, of course, is just do some commits. So this is going to be really boring. Sorry for showing this, but we got to do it, right? Here, let's make this there. This is going to be pretty boring. So this commit, okay. Ooh. Okay. Okay, great. What we want to do here is probably let's just commit that all in one go. That's easy enough. now we can start tidying up the code. So the first place I want to look at is there's a whole bunch of stuff in this file, and I want to get rid of this copyright notice because once we're done in here, yeah, there's no there's nothing really left. So these constants are unused, these errors are unused. We're not going to be, the old package had like a global logger that it was using, so we're not going to use that. We don't need a function decode base 64 because the standard library gives us that, so we won't be needing that. And I'm pretty sure this duration to ticks is also not used. I'll just double check. What do we got here? I can just do this. No. Not used anywhere because I think we don't even use that duration type anywhere either. Rather, if I look actually for the time, no, it's only used there. So we can get rid of that too, and that means we can actually safely just get rid of the entire file. So that's easy. So now the other thing is that we'll probably want to get rid of the test that was using that, so that was ticks. Yep, because this tested something that we weren't ever using. And also, that stuff isn't used either because we don't need this 2 bytes. That's, yeah, never needed that actually. So, grab that. And then we can delete that. And then this is all commented out, so let's delete there we can safely delete a lot of this. Yep, all the way there. So let's go from dot to the file, delete, easy. Okay. And then this now contains no code from Comcast, so we can delete that. Great. Oh yeah, I'll start the formatter so we can get that. Easy. Okay, so where are we up to? Oh yeah, so there's that file done. Other things I've written down here. Put uint to append uint, rename constants, general tidy up, deleting old code. I think this is probably okay just to do a commit now. Yeah, we can do that. .857 lines. Wow. Okay. Just like that. Not bad. Let's move on. So, okay, so that debug print we've actually done already. I'll just look again. So print. Oh, still one more. Okay, there. Okay, let's commit that as well. you know, I'm going to put that in the previous commit. There's no need to. Okay, so that's done. Now, one of the things we can do now as well is that, let's just see if we've got any more. Okay, so still one more. Okay, so we'll keep the original license file from Comcast there, since we're using just that one file. Okay, so let's do this, put you in. There's a few places I've seen we can simplify. Yeah, so this is a good example. So here, instead of making a buffer, putting it in, and then appending it, the standard library gives us a function for that. So we're going to go, we're going to actually just append that to the buffer. So we can get rid of this, and this will change to append uint32. Easy. Oh, and then we don't need that either. So this is just actually buff equals. Okay, easy enough. It's probably somewhere else where we're doing this. Yeah, okay, so we can. Oh, actually with that one it doesn't make a difference because we're going to just use it in one go, so that's fine. Leave that as is. Okay, next up is here, apparently. I don't see any advantage of using append here because we've already made one of length 5 and we put it in there, so I don't see any difference. Okay, move on to the next one. Okay, yeah, so with this one we're also going to have to use put, because what's happening is that we're actually, so we're making a slice of length 8 because we need to get our N64 out of there, which requires 8 bytes. But then we're only getting the 5 bytes that we want, well, that the 5 bytes that are required for the on the wire encoding. So in our struct, we use a uint64 because that's the only way we can actually represent a 40-bit integer. At least that's probably the most convenient way to represent it in Go. So that's fine. So we'll move on to the next one. Yeah. Okay. Now the only thing I'm finding strange here is that we're putting a little endian into our buffer, because in the spec we use big endian. That's what they've decided. So I wonder whether this encode splice info, this isn't tested anywhere yet, so yes, it's been commented out because it's from a long time ago. I think what will be okay to do is just to we can just fix it up in one go. So we get rid of that intermediate buffer. Do it already there, so it's going to be append okay, and then the same goes here. So this is going to be big endian. We don't need this buffer anymore. We're going to append now to the buffer that we've got. And what we can actually do here, we can just easily go return it in one go, bang. So there. Oops. Great. Okay, that's easy enough. Deletes a few lines of code, which is always great. There we go, deleted 7 lines for free. Great. Didn't even need to do anything. Right, so we'll check that off our list. Okay, rename constants. All right, so this is about in particular not there. Yeah, encryption algorithm. Okay, so this is okay, so first of all, this isn't even used because we've actually got this instead, so we can just delete that in one go. And then also this struct, also we're not using because we're just keeping it all directly in the splice struct, so we don't need yet another struct for that because there's only two fields. They're self-explanatory, so that's great. Good. It's done as well. That one looks okay to me. This one is also okay, not too long, at least not needlessly long. This to me is looking a bit suspicious. So I think here we can actually just get rid of the word type because, you know, I mean, it's already got as the actual type, so I think having type there, it's not necessary. And then the other thing I actually wanted to do anyway was, instead of using these acronyms, in the spec we've actually got, you know, some names that, you know, are a little bit maybe easier to find, easier to grep for. We've got a named constant, so we might as well use a name. But we'll leave it like that for now, and then we can, yeah, because right now we're just shortening the constants, we're not, you know. Okay. We've already done that, and that's okay to me. All right. Good, more lines gone, all for free. So that is rename constants done as well. Some struct fields that we want to rename apparently. Yeah, that's encryption algorithm. I hate that word, those words. It's so long. what we can do is just, at least my understanding of cryptography, my understanding is that a cipher is an encryption algorithm. So let's fix that up. So this can be cipher. Now we can go and fix up where everything's. I'm just going to replace everything like that. Right. So you're thinking maybe, oh well, what's the point of this? Look, I mean, encryption algorithm doesn't really give us any more information over cipher. So why, have more noise, I'm not writing Java here. What I do want to do is so we already document what cipher actually refers to. So if anybody's really confused, they'll see the documentation anyway. Okay, I think that's okay. One thing I like to do now is just to actually just read the documentation, like our package documentation, just to see how it reads and see if there's nothing there that looks kind of ridiculous. Looking much better, especially if you were to see the, you know what, let's actually open that up. So if we go to, it's going to be 35, okay. It's a lot longer. So on the left we've got our package, and then on the right we have the one from Comcast. This is a splice insert. Let's see what that looks like. Yep. See, so this is a great example of what one of the problems was that Comcast thing. So if we go to this splice insert program, yeah, and then we find it's a thing with the splice time, okay, and then there's another string with PTS time, and all it contains is a 64-bit integer. Why have so many types for something that is just a pointer to a number? A lot of code for not a lot. All right. Oh, I'm happy with how that looks. Let's just review this. That's looking good, happy with that. Okay, so let's make sure that there's, look at the lines of code that we've got. 1,283, oh man. Okay, so we've now deleted over 3,000 lines. So I'm going to update our little bit of text here because it just feels good to do that. All right. 194 comments. See whether, I don't think this is actually used either. So initially we were going to use, like, have a distinct type that holds this sort of special value. The thing is that sometimes in the spec it's held as 40 bits and sometimes it's 33 bits. So not really, yeah, don't quite see the point of it right now. So probably for now, I'm going to just check that it's not used anywhere. Oh, there it is. Okay, that's all right. One of the things that I saw as well was how we were encoding the bytes into the Y representation. So one of the things we were doing was, I'll just do that. I noticed not there so much here in this command. That's right. Okay. So for example, let's have a look at event here. Okay. So event is a 32-bit integer, which can be represented with 4 bytes. So here we're actually like kind of manually doing it, but we don't need to do that. We can actually just use Go's binary encoding package, and it'll just do this for us. So what we'll do is we can four plus 1. Yeah, so all we need to do here is insert the big endian number that, well, insert in big endian encoding the uint32 that we've already got. So we can just do this. So into P from 0, 1, 2, 3, so up to 4, our ID. Easy as that. Yep, that's right. That's good. And then we may, yep, and then here we go. Same thing again, we can tidy this up. So we're getting here so this here gives us back an 64, if I remember correctly. Yep. So what we can do here is actually just or actually we can just append it straight away into our buffer. So we can just grab, again in big endian, so we'll use the built-in append function that Go gives us. So is binary big endian append a uint32 into that slice, and then we'll just convert that to that. So that's what we do anyway. So again, bang, much easier. Looks like we've got the same again with the program ID. So let's just double check what that is. In an event, a program ID, yep, okay. So again, we don't need, might as well use what Go gives us, right? So this is the same as binary dot, again in big endian, append the uint16 into P, and the value that we're putting in there, that we're encoding, is the program ID. There we go. Great. What? Weird. Okay, some weird Twitch. Anyway, whatever. Okay. Make sure we've got this right. Yep. Now I wonder whether we can append. So these are uint8s. That's the same as a byte anyway. So we might be able to. I wonder if we're allowed to do this. See what the compiler has to say. Yeah. Strange. Normally the formatter does that for us. Typo. That's why. Okay, and yeah, we are actually allowed to do that. Okay, again, another culprit where we can just use the built-in append. So, oh, actually, we can just even use put, since we're allocating ahead of time, just to, because why not? So, I'll just double check exactly what this ID is. So this is in a private command. Yep, okay, so that's easy. Just a uint32. So again, we'll just do exactly the same as before. Here. And we're putting it into 0, 1, 2, and 3. So to 4, and then what's the value we're putting in? Oh yeah, the ID. Great. Okay. more of this again. So let's binary.big-endian.put uint32 into again. That's all that's left. Okay, so let's just double check our progress. So we're still just doing that general tidy up, which is pretty boring, but you know, as I say, we've just deleted almost another 1,000 lines of code. So I think so I'm just trying to think what to do next now that we've really cut this thing down so much. It's kind of looks a little bit bare bones. It's you kind of think to yourself, oh shit, like is there anything more to do? There's barely any code. And there's still over 1,000 lines, but yeah. Okay, so one of the things that we wanted to do actually, of course, is just get this test to pass. And we know that the value is okay. I mean, we know that the test is, sorry, we know that our logic is okay, so we might as well just fix up the test logic because, yeah, that's what we want to do. So, just double check. Okay. We've got well, yeah, let's start with this. So let's have a look at this. Insert is the insert command. So that's this one here. So for some reason it seems that we're not getting the same value. Have a look. Okay, so those pointers are a bit of a pain. So is it it could be that the break duration is actually different. So let's just do a specific test for the break duration. Be the so duration. Okay, so this yucky thing duration. Don't need that because Go already does that for us. Okay, so could be something in the I'm not quite sure. Well, maybe we'll just have to do the boring thing of looking at this. And then we've got this one. So let's oops. Event ID compliance. There we go. Okay, well, that event ID compliance is a bit of a tricky thing. So in our example, apparently, we're not sure whether event ID compliance is true or false. Might have to read up in the spec and just to see like what exactly that event ID compliance really means. So we'll go to our splice info, and then that's in the insert command. So command splice insert event ID compliance. So let's go down. Oh. Okay, got it. On this flag, okay, maybe we'll want to check okay, so probably what the go is that there's something in the sample. They actually tell us, so in the particular sample that our test case is splice insert. Okay, so let's have a look, at our case. So that's 14.1. Okay, so here's the next. So this is a test we're working on. So what have we got here? The event ID compliance is actually true. Okay. So maybe this means that we've probably set, or rather we the ID, yeah. So this may actually need to be true in the end. So what I'm thinking is that just thinking if there may be a way to actually read it from here. If we read the hex, we might actually be able to get it out. So we're looking here for an ID of 48. Ugh. We should be able to see it in here. So 480008F. 4800, okay, there we go. And then we've got the next 480008F, and then the next 7F. So the next byte is 7F. So 7F in binary. Doesn't it go OX? Maybe. One, two, three, 4, 5, 6, 7. Okay, so what does that mean then? That the okay, let's check in the spec to see. Okay, so that means that event ID compliance is actually true, because here we've got 0, 1, 2, 3, 4, 5, 6, 7. Yeah, so it's actually, which is 0x7f. Okay, so this is actually true. So not only is, so Yeah, so this is true. Okay, great. So that's a bit of a whoopsie. I mean, all right, what have we got here? Still something different, apparently. Thought that was it. Anyway. Great. Okay, so accidentally used, don't know why I was making a pointer there. Anyway. Fantastic. Okay. Let's save that. Seeing what we've actually saved here, what we've actually set rather. So easy as that. Let's send that all up, just in case anybody wants to read any of that. Let's also put that in here. Okay, yeah, very happy with that. This should be called cipher. There's no such thing as encrypted packet anymore. And then test will just be test. the next thing that we could do is actually test encoding. That should be pretty easy because we've already, we can already decode stuff. So what we could actually do is, the test would be pretty easy. So if I just come back to here, so the test would just be that, say we have a splice info. The test would just be to decode it and then just encode it again and then check, and then we could even just decode, something like that. So let's pick here we go, this test, and then let's actually get, so this is all dead. Let's just make a new test here, down. We've got an encode, no, okay, easy. All right, so let's go, let's make a new test. We've got our test cases. So all we need to do is we can just get this and then check if we get that base 64 encoded value. So that's pretty easy. So we're going to go, just leave that there. So we're going to get oops, let's do a subtest here. So we're going to go to run. Oops. And then we'll get our base 64, encode that, and then see if that's the value we want. Base 64. I can't remember what the encoding, yeah, encoding. Yeah, so we're going to do encode to string. All right. Oh, okay, let's do that. Okay, so our encoding is way, way, way off. Way off. So we're going to need to review this encode splice info. We're going to really, really need to review that. Yeah, I'm going to really spend a while going over this encoding logic. There's obviously a whole bunch of stuff wrong. But that's fine, we can just step through it bit by bit, or byte by byte, and bit by bit actually. So that's easy enough. I know that that's a constant, so let's go to our splice info. Okay. So that's what we want it to look like. So we could probably I might just get rid of that plan there. Let's go over here. All right. Okay. Table ID. The next bits must be 0. So there. Subtype is 2 bits after that. So already I feel like these constants are not quite, I don't feel like that's set correctly, because we could just read it straight out of we shouldn't need to like set it. So let's actually fix that up. So let's simplify. If we go to the subtype, here we go. Okay, there's our subtype. Okay, so it's OXO. Yeah. So what we can actually do is just set it as it is. So 0. And then we can go equals OXO1. And this is OXO3. Now there should be a way to do that more neatly. Is that 3 is the same as, can we do octal for that? We can just have them just set like that, it's okay, but that's what we want. Yeah, it is just that. Yeah, so we can go pulls O. That'll be right. Again, we can actually have it as a, okay, so let's do this really exactly what it would look like. So this would look like, and then the value would be, so the first 2 bits are reserved, and then the next one would be 0, right? Yeah. So the next 2 bits we care about are those. How can we represent that? Maybe, and then 1, 2, 3, 4. So we can have some values and actually just set them. So this one is going to be, the mask is going to look like zero. This one is going to be like that. And then this one is going to be 1, 0. That, and then this one is going to be like that. So in hex, this is 0, this is 0x10. Yep. This one is 0x20. This is 30. So can we do that with an enum is the question. Do we want to? Well, in our case, now we can just directly apply the value, so that's going to be like that, easy, so we can delete. Oh well, we can actually say if just do a quick check to see we're not getting an invalid value, but it's quite hard to, so maybe we don't even care. Let's do it anyway. So yeah, this is going to be a great simplification. So we can just use the, just kind of create a bit field and then just do it all in one hit. And we can go here, we just return the error. So we've already got that. Whoa, look at that, beautiful. Oh, okay. Yeah. Oh, so this is on. Ooh. Okay, looks like that isn't correct. All of the tests are failing now. Okay, so hey again, how's it going? Morning, just. Oh, what's the time where you are? In England. 11:43. Wow. Yeah, it's Saturday night here. This is just a quick one. I've deleted, all I'm doing is, where was my thing here? Yeah. So all I'm doing is just a quick tidy up. I'm not adding any new features, just making sure that it all sort of makes sense. And so far this worked out really well. I found that when I first started, I was kind of manually shifting bits, but I realized that the encoding binary package in Go actually does a whole bunch of that for you. So I was using the binary package in the code that I wrote later, but I hadn't used it in the code that we first wrote. So that was a nice way to delete about, a bunch of sort of magic numbers, and yeah, it's good. So now what I'm looking at was just a way to try and make these particular values clearer. I'm not quite sure whether what I'm doing is actually clearer. So what we've got is a 2-bit field here, and I'm getting our struct, which is here, and then just seeing sum up to here. I'm just seeing whether there was an easier way to encode this value. So we've got 2 bits that are constant. So we've got the next 2 bits are going to be this SAP type. I guess what I was hoping for was that instead of setting values like 1, 2, and 3, I could actually store what they would look like as a bit field as a constant. I thought that maybe that felt a little bit more, I don't know. rather than having a bunch of code to convert the values, you just store them as a constant, as one thing, and then, well, that's it. Values are values. But I don't think I understand it correctly, so here I am. So, yeah, not sure. I'm going... Got the... So, valid. Oh no, that's... There's just these 1, 2, 3, 4 values. So how I think it should look like is got 1, 2, 3, 4, 5, 6, 7, 8. Okay. So these are reserved, and they're a constant value, so we can just skip over them. We're reading from these two here. And then this is actually a different thing. That's some length. Something else. So what I'm thinking is that the possible values here can be one of these four. 1, 2, 3, 4. So we've got, as binary, it's just 0, 1, 2, and 3. But I feel like I could store it as like this, 0, 0, 0, 0, and then 1, 2, 3, 4, 0, 0, 0, 1, 0, 0, 1, 0, 2, 3, 4. I feel like I'd rather be doing that. Assume that could be, yeah. So I feel like something not specified. Okay, could also use byte, which is an alias, instead of 0 for close. Okay. And the values in. And or all the values in. Yeah, right, okay. So like this. And then go down, do something like a switch or something, and then go down from there. So something like okay. That works, but then at so specified byte. Right. Then will that get me to what I yeah, still, yeah. So then that would be, I mean, just to really spell it out, so it would be like equals 1 shifted 2. But then I need, I don't want to shift it, because the values I need are rather, maybe I should just keep it the way I had it before, which was kind of not so. I guess I was just trying this as a test of my, to see if I understood this binary thing, this particular thing, but I don't think I've got it. So, I mean, I guess I was just kind of doing a more compact representation, but maybe that's not worth it. I'll just quickly, hey, really random viewer, thanks for coming back. I can't remember the last time you were here, but since that time, we've actually gotten all of the, if I, let me get this, so we're going to do this. And then like that. So the only tests that are failing now are the ones where we encode the packets, which is awesome. So we're decoding 2 of the like the core or like two of the main types of packets that we'll see, and the tests are passing just fine, which is great. So beautiful. I just half an hour ago or an hour ago, I just added a test to test the encoding of the packets, and yeah, that's failing hard, but this is code that we wrote quite a while ago now, so let's say I wouldn't be surprised considering how much we've had to, well, how far we've come, let's say, because right now I've deleted over 3,000 lines of code. Yeah, so what I was just looking at was the encoding stuff. So in particular, what we're looking at is not that. Yeah. So what we're doing is just looking at encoding this. So right now, so much unnecessary code. Yeah, well, I can so I can actually show you. Look, if you're really interested in the actual answer, there's a bunch of stuff. So here's the. Oh wait, have we got that right? No, sorry. All right. There, yeah, there we go. And here. So one of the things that was getting me was, if we go to the splice info, yeah, this is a good one. Was this the one? Command. There's a very specific example that showed how kind of crazy this thing was. Splice insert, here we go. Okay, so there's a data structure in here that we call insert. So in this one from Comcast, you've got, let's say, this break duration, or not even that. Let's actually say, is that the one? Yeah, splice insert. Okay, this is it. Okay, so the program is actually go and look. So we store the value as just a pointer to a uint64, nothing fancy. We use a pointer just so that when we're encoding and decoding, we can just check whether the pointer is nil to set the flag in the binary representation. But anyway, so ours, uint64, this one looks like this. Splice insert program is a struct with a splice time field, that's splice time, and the splice time is itself a struct, that's a PTS time, which is actually just the pointer to the uint64. That's the type of stuff that is just all over the old code. Crazy. And this is just the documentation, so this is the stuff that we can see. But the code, there was all this code to encode and decode, so they're going deep into these structs and coming all the way back out again, checking if things are nil, checking all this, like, if things are zero. I don't know. Don't quite get it, but it, yeah, kind of satisfying to, simplify these kinds of things. So there you go. Yeah, this sort of thing. Time specified flag. Like what? Like what is it? Time, like why? Like just check if the pointer's nil. I don't know, I guess when you're working at a big sort of company like Comcast is like this TV company in America. I don't actually know what it I don't actually understand what it does, but I know that it's like a big like TV thing over in America, in the USA. This feels to me like Java, you know, when you have like classes and subclasses and subclasses and just all this stuff. The other thing is that they're using all these structs to kind of represent what it looks like as XML, because you're actually allowed to, instead of using this binary encoding. Yeah, oh yeah, that's right. Yeah, they do, yeah. Yeah, of course. Yeah, the ISP, yeah. Yeah, because they use like that cable internet, yeah. Which we used to have in Australia, but we don't have that anymore. Thank God, I guess. Yeah, so you can actually, there's this diagram throughout the, throughout the spec, and this is kind of the XML representation in some kind of diagram that I don't really understand. But in reality, nobody uses this, well, at least in all the video streaming systems that I kind of see around, including, you know, like Twitch and anything else. They all use the binary encoding. So I think they were doing this nested, all these huge amount of code, because it kind of means that Go kind of makes the nested XML for you. But I mean, like the amount of code that you need to write to get Go to do it for you, you may as well just write the code yourself, because you're just nesting stuff. So yeah, I think kind of like enterprise programming, you know, this sort of big business stuff, I don't know. But yeah, a lot of yeah, a lot of stuff like this, yeah. Lots, yeah, these sorts of things, like a lot of types and a lot of methods. You know, sub type name, here we go. See, like this sort of thing, like sub type name. We don't, you know. There were things like every single, you know, for example, this, the unique program ID is actually just, if I remember, a 16-bit integer. These are 8-bit. So you had all this code for some reason that was using 32-bit integers for no reason. So, you know, there was this code to kind of like truncate things and all this stuff. And oh yeah, decoding large JSON. Yeah, 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 yeah. One thing I've had to do a couple of times is you do these. You can actually define these nested. What do they call that? Like these composite? What is it? Like you can do. Where is that? Here. You can do this sort of thing. Like say you've got like a. Yeah, 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 yeah. I get that. I guess though, one of the things that I sometimes do is, you know, you have like say you have a type of I don't know what have we got like a break. And, I've seen this sort of thing going on. But another thing sometimes that I do is that, say you've got a struct like this, another way to do it is you could do, and then let's say you've got these things here, place and postcode. Sometimes I do this, it just depends, I guess. Yeah, like B break, and then have like a custom method. What is that like? Anyway, yeah. And then in here and then you kind of put this thing in. Or let's say Marshall, right? Sometimes I've done that a couple of times. I don't know. Is it really neat and tidy? Yeah. Because then you put your struct in here, and then you kind of fill out your, so orgs dot name dot, location dot where dot. Oh, no. Yeah. Yeah, so something like this, yeah. But I mean, what I mean is that sometimes I won't ever expose any of that. Instead, I'll have just like this. Because if it's only used in serializing and deserializing, yeah, every now and then this can be sort of handy. And then you do so it kind of hides all that away. It's not really not great. I just hate when there's so much nested stuff. Seems very I don't know. But anyway. Other Neo Marshaller? Oh, Jason Marshaller. Yeah. Oh, actually, speaking of this reminds me of there was a talk by one of the early members of the Go team about these sort of big nested things. I can't remember where that is. It's actually pretty interesting. Is that Andrew Code? Yeah, it is there. Yeah, so I'll link this in the chat because I remember from a long time ago now. Might be interesting. I don't know. Oh yeah, this is the one. God, I haven't read this in a long time. Oh, okay. Oh, from Google. Oh, that's a good one. No, I haven't. Oh, haven't. No, I haven't seen this one. Mm. Yeah, style guides are a funny thing. Yeah, I agree. Yeah. One of the things I do as well is I'll read the, you can sort of look at the standard library and go, oh, okay, that's how they do that. One of the things that I want to do after we're sort of, after we've got something genuinely useful in this, is work on a MPEG transport stream package. And I've actually wrote a bunch of stuff already. I just haven't published it or anything. But that's a cool. It's like a media container which is used. If you're watching on your iPhone, that will be used right now to stream video. And similar, like it's got a whole bunch of like binary stuff, and it's all with bits are packed in. But I copied, one of the things that I needed to do was I needed like a scanner. I needed to like read it a packet at a time, and I didn't want to have to do a bunch of buffering myself. So what I did was I just copied the what did I do? Copied the buff.io. Wait. I copied this scanner, sort of how it works, so you can do bytes and error and scan, and like just copying what the standard library does. Then when I handed the code over to my colleague who never really wrote much Go, he didn't have to think about using it. He was just like, oh yeah, like I've used this thing before. Yeah, I already know how to, if I know how to do it for text, I know how to do it for the MPEG transport stream. So yeah, it's nice because then you just rely on like the really smart people who've like worked out all this stuff, and then you just go, oh yeah, that's good. Okay, I'll do that too. Whoa, sorry, the microphone's fallen down. I'll save this. Where's that button? It's a good one. Yeah, thanks for that. That's good. I've just saved that to my bookmarks. Yeah. I that's actually what I wanted to do first, but I don't know why I chose this add signaling thing. I mean, fuck only knows why I chose that. I think I just flipped a coin or something and said, oh yeah, I'll do this first. But yeah, the MPEG stuff will be a lot more fun. Because come on, like who cares about ads, right? Yeah. Yeah, and right now I'm actually running to do this. I thought it would be fun to. Right now I'm using FFmpeg to stream from the computer that I'm on now. Is that not? Yeah, yeah. But yeah, the RTMP would actually be a good. Nah, it's okay. I know what you meant. Yeah. So, but yeah, this right now I'm using FFmpeg to. So it kind of goes like this. That's fine. We've got my computer here. No, what does it look like? And that actually goes to loop back. So we're localhost, and then here is actually FFmpeg, and then this goes out to Twitch, and this one is actually going out to YouTube. So it will be fun. So this is RTMP. So it'll be fun to replace this in Go or whatever. Just have its own software, because FFmpeg's pretty big. It's an amazing bit of software, of course, but it'll be kind of fun to like just make a little part of FFmpeg, you know, for this RTMP job. There's a bunch of like online, you know, services that you can pay for that basically just do this job. But it'll be, you know, so for simulcasting. Ah, okay. Is this gonna come up? Oh, yeah. Yeah, nice. I will also save this. Yeah, okay. Oh yeah, I really need to set up my IRC client for Twitch as well. I've got the browser thing open here, but yeah, it's no good though. All right. might do here is the mod tooling. Oh yeah. Yeah, but I feel like, you know, IRC is such a great little protocol. I feel like I need to use it to keep it alive or something. I don't know. Oh yeah, wow. Yeah, see, I never, I mean, I'm only, how old am I? I'm 30. So, yeah, but I know that I was really sad when Slack turned off the IRC gateway to their service. I thought, oh God, because that Slack client is just, yeah, I don't know. I don't think that's a great piece of software. So going from, you know, whatever IRC, tiny IRC client I was using to like this big fat Slack app, it was like, oh God, when you have to use it every day, yeah, quality of life down. Ah, yeah, that WeChat play. Yeah, I actually forked that for some reason. I needed to get rid of something, or why? Why would I do that? Yeah, I only found out about that actually, like after it was another 2 years of using Slack, and I said, oh God, jeez, this is awful. Yeah, that's I should remember that next time I have to use Slack. Yeah. Just do. So I'm just doing this so I can at least get some idea of, you know, which bytes are going wrong. Hey there. Hey Beast. Beast 00994. Yeah. Nice, will do. Actually, yeah, my girlfriend just got back. I think I heard her. I should check. Yeah. Good luck with the gardening, mate. See you next time. Beast. What we're doing here is working on a. Wrote a little web page. Where is it? Here we go. So, oops, okay. So what we're working on is this binary message protocol that's used to signal ad breaks in video players. Oh yeah, nice. Okay. Yeah, so this could be done in Python too. Actually, there's a open source Python package that does this. That implements this protocol. That might be good to look at as well. But yeah, basically this is a binary protocol that used to signal ads in players and stuff like that. Oh well, yeah. Okay. What are you working on now? Oh yeah, stuff like what? Okay. Oh yeah, wow. Oh, congratulations. First lecture, yeah, awesome. Okay, so I'm just going to continue where we left off. So what we're doing is I'll just add some new stuff. So what we're doing is so decoding is A-okay, but encoding is no good. And what we're going to do is just work through each field and just track byte by byte where we're up to. So let's just do this. So tonight. This is in Australia anyway. All right, so where we got up to was, where were we? I'll just close that for now. So that's linked in the chat if anybody wants to have a look. But yeah, ask questions, whatever. We're just banging our head against the wall with these you know, bit packing stuff. Okay, so we are looking at to learn networking by doing projects. Hey, best book to learn networking by doing projects. So are you asking what books about networking might be useful to learn? Is that right? Or doing projects? Sorry, I don't quite understand the question. Okay. I guess it depends what type of learner you are. Sometimes some people are kind of different. I mean, some people, like I sometimes just read the specifications. That's often how I learn these things. So I'll just go through and just try and implement even just a tiny little part of it. Other people, I know there was a really, what was that book? Unix Networking in C or something. But to be honest, the books that I've read the most about programming are just kind of these general sort of programming, about software engineering. Yeah, because I found that when the software engineering was sort of, when that was good, then taking on any kind of software development project got easier because I learned about testing and about debugging and about clear code and unclear code. So the book that I always like to recommend is, I'll just link it in the chat. I think, did I put it in this thing? Oh no, okay, the practice. Ah, yeah, that one, yeah. Ah, yeah, okay. Yeah, I still, yeah. To add that to my list, hold on. There we go. All right. Ah, yeah, that was another one, yeah. 2, 3. So what we're doing here is we're just going through and setting these bytes. I've already found a pretty dumb bug, which was that I was missing this byte altogether. So let's do that and see where we get to. 48, got 12. Okay, great. So I think, yeah, this is also wrong. So this needs to be in, we've got the, looks wrong. So this is going to be packing up a splice info. So we're going to have a bunch of stuff, and where we're hitting right now is we've done the table, it's called, table ID. And then we've got a bit field here. So we've got maybe I need to do it like this one is going to be that, and then this is the length. So what we're looking at is this one here, and then within there we've got 8 bits to set. So these 2 are reserved. There's these, those are just constants. And the next bits are here. This is our SAP type. And then we've got 1, 2, 3, 4, and then 1, 2, 3, 4. These ones actually also belong to length. So length is actually 12 bits long. Okay, so let's fix these up, because already I can see that this is wrong, right? So we want to shift along 1, 2, 3, 4, 5. And this is going to be 6. And then that's totally wrong. This is going to be 0, 0, 1, 1, 0, 4, 5, 6, 7, 8, like that. There we go, 48, 48. Awesome. All right. Oh, we got more. Oh, yeah, okay. Yeah, no worries. Sephiros, is that how you say it? Anyway, but yeah, wishing you all the best reading those big books. I guess I think they're big. And yeah, thanks for joining us. Hopefully it's helpful or interesting, or I don't know, anything, right? Okay, so we've set those bytes well, so that's great. Oh, more people follow. Oh yeah, thanks for thanks for following everybody. That's I need to follow everybody back. That's what I do, because I actually only joined Twitch like a week ago or something, so this is it's super interesting to see what other people are working on. So I will now. Account created 2 hours ago. Yeah, wow. Okay, follow that. Awesome. Sweet. All right. So where were we? So next up, we're going to read the section length. Or sorry, rather encode the section length. So that one is, Oh yeah, as I said, we'll set that at the end. So we'll do that later. And that's actually, oh yeah, 1 and 2, yeah. So 12-bit length at 1 and 2 set at the end. Okay. Next byte, protocol version. This is a constant, so that's, we're all good there. Right now we are, okay, we move on to, just gonna put this, close that. Kind of running out of screen space here, anyway. Anyway, let's keep that really small. Is that clearer? Yeah, that's good. Okay. So as I said, oh no, still not right. Oh man. Yep. So now we're appending another byte to the buffer. And we're setting this encryption information. So this is a Boolean. I feel like I just want to have just a byte and then append it at the end. Oh, let's go. So if the thing is encrypted, then and we only want to toggle, so we only want to set those there, like that. And then the last bit that we're up to, so we're doing a new one now. Okay, that looks a little bit better to me. So what we're doing here is we are setting the encrypted flag and the cipher, and then we're setting those values in the byte. And then what we need to do is we still need to get one bit, one bit of this byte needs to come from the PTS, this presentation timestamp. So what we do is we first make our timestamp, and then we and then we toggle the bit that we get back, although this doesn't seem quite right to me, but anyway. Okay, and then we append everything after that. Let's see how that looks. Okay. Okay, I think now that we've at least got the next byte set, I might call it quits because it's actually getting late on Saturday night here. So just do this. Put it on this little finish. Then I've just learned what people do is they kind of send you elsewhere. So let's find where we want to go. I'll browse, is that what you do? Yeah, create it, there we go. So, nice. Thanks, Kat, did you? Usually I do very long streams, but because it's Saturday night, I'm pretty tired. I can't even quite get my words out properly, so. Gotta know when to call it quits, right? Here we go, that looks super interesting. No engine game dev. That is cool. I learned how to do this yesterday. All right. See you all. Thanks again for joining us all. It's makes a lot of this fun. So yeah, thanks again. See you all. Oh, RAID settings do not allow you to RAID. I don't, is that because, like, I don't know, is there a reason for that? look, I'm just gonna have to call it. Okay, see you.